Hello student, myself Dr. B. Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about bit masking in Python. Now coming to the introduction of bit masking, first of all you have to understand what do you mean by a bit. So bit is nothing but a boolean value which is either the value 0 or 1. So bit masking is a technique for applying a mask over a value to keep or change or modify a given piece of information. Now, a mask determines which bits to set and which bits to unset or clear in a binary number. So, a number of bit masking or bitwise algorithms are available, and every programming language, most of the programming languages provides bitwise operators to do the task. So, whenever you are applying bitwise algorithms or bitwise operators, these bitwise operators are much faster and these are improving the efficiency of the program. Now, in Python, what are the basic bitwise operations? So, basic bitwise operations are first is bitwise AND operation, bitwise OR operator, bitwise XOR operator, followed by shift operators are available. Now, how bitwise AND operator works? Now, whenever the two bits of given two numbers are 1, then when you will apply the bitwise AND operator, then the result will be also 1. So when both the bits are set, then the output will be also set. So if one of the bit is 1 and the other bit is 0, then the output will be 0. Similarly, coming to bitwise OR operator, so bitwise OR of two operands whenever you will take, so when one of the bit is 1, then the output will be 1. So when both the bits are 0, then only the output will be 0. Now the third one is bitwise XOR operator. Now the bitwise XOR operator says that this particular operator will give you the result 1 when both the bits are different. When both the bits are same, like both the bits are either 1 or both the bits are 0, then the output will be 0. But when both the bits are different, like one is 1 and the other one is 0, then the output will be 1. Now, let us see some examples of bitwise operations AND, OR and XOR. Now, take these values 5 and 6. So, 5 is 101 and 6 is 110. So, whenever you will apply bitwise AND on this, see, AND operator says that when both are set, then the output will be set, or when both are 1, then the output will be 1. So here one of the bit is 1, other bit is 0, so the output will be 0. So here one bit is 0, other bit is 1, so the output will be 0. In this case, both the bits are 1, so the output will be 1. So when you convert it back, it will give you the decimal number 4. So that is originally the numbers you have to convert into binary, then bit by bit you have to apply AND operation. Similarly, coming to the OR operation, so here one of the number is 10, which is nothing but 1010 in binary, and one number is 6, which is nothing but 110 with a leading 0 will apply, and whenever you are going to apply the bitwise OR operator, both the bits are 0, so the output will be 0. Both the bits are 1, so the output will be 1. One of the bit is 0, but the other bit is 1, so the AND gate, the OR gate says that the output will be 1. And 1, 0 will give you 1. So, this is the result of your OR operator. Now, coming to XOR operator, the XOR operator says that when both the bits are different, then the output will be 1. Otherwise, it is 0. So, here both the bits are same, so the output will be 0. Here both the bits are same again, so here output will be 0. Here both the bits are same, so output will be 0. So like this, if you will check that in all the cases, both the bits are same. That's why the output you got as zeros. Now, After the bitwise AND, OR and XOR operators, we have shift operators also, which will also act on bits. So we have two types of shift operators. One is called right shift and one is called left shift. So a number is given, n is a given number, and you have to shift that number by how many bits. So here n is the given number and m is the number of bits by which you want to do shifting. Number of bits with which you want to do shifting. So n right shift by m number of bits or n left shift by m number of bits. Suppose in this example, suppose n is 8 and m is equal to 2. That means 8 right shift by 2 bits or 8 left shift by 2 bits. If you will do, then what will be the result? So the given number, first of all, you have to represent in binary. So the number is 8. So we can do 8-bit representation or 4-bit representation. So in this case, we have given in 4 bits. So it is 1000. Right shift by 2 bits will give you 0010. So 2 bits are shifted towards right and the answer will be 0010. Now, when the number is very small, you can do it manually and easily. When the number is very big and you have to very quickly calculate what is the value of left shift by m number of bits or right shift by m number of bits, we can use a shortcut formula, and that formula is n is equal to n divided by 2 to the power of m. So here, suppose our number is 8, 8 divided by 2 to the power of m is how many bits you want to right shift. So it is 2 bits. So n divided by 2 to the power of 2, which will give you the result as 2. Similarly, let us talk about the left shift operation. In the left shift, here n left shift by m number of bits means shifting the bits of n towards left m number of times. So let us assume the same example again. N is equal to 8 and m is equal to 2. So n can be represented in binary as 1000 and n left shift by 2 bits. 8 left shift by 2 bits. If you will do, then you will get this result. So do it manually. You will see that left side 2 bits are shifted. So we have represented this, and if you will do it in a quicker manner, there is a formula for this. So which is nothing but n left shift by 2 bits is nothing but n is equal to n multiplied by 2 to the power of m number of bits, which is if n is equal to 8 multiplied by 2 to the power of 2, which will give you the result 32 in our example. So these are the shift operators available in Python. Now, next, how bit masking concept is used to represent a set of elements. Suppose you have been given a set S with n number of items. Suppose the items are numbering from 1 to n. Now, bit masking is a concept in which every subset of S can be represented with the help of a particular mask in binary form. So, if a set is there, if a set is equal to, a set contains 2 elements, let us say 1 and 2, 2 elements are there, then how many subsets are possible? So, there are 4 subsets possible. Okay. So, for a set containing 2 elements or n elements, 2 to the power of n subsets are possible, which is nothing but here we have 2 elements. So, 2 to the power of 2, it is 4 subsets are possible. Each subset can be represented through a binary number, or we call it as a mask to represent a subset in a set. Suppose 00 will represent that an empty set, that no elements are there. 01 mask will represent that only one element is there. 10 will represent that only one element is there, and 11 will represent that both the elements are present. So this 0 and 1, so either by clearing the bit or by setting the bit, we can represent that an element is present in the subset or not present in the set. So in the bit masking process, we will create or we will represent a set or subset through a sequence of bits. Okay. So for example, you can see we are considering one example where the sequence of bits is 10101. We call this as a mask to represent a set of size 5. Now, this mask represents a subset of a set having total 7 items. Out of 7 items, we are considering a subset of size 5, and that subset is represented through this particular mask as 10101. So, how will you understand? Suppose there is a set of 7 elements. You can see in this example. In this, first bit is 0, which indicates that item 1 is not present in the set. Second bit is 1, that means it indicates that item 2 is present. Item 3 is present because this bit is set. Item 4 is not present. Item 5 is present. Item 6 is not present. Item 7 is present. So the bit 0 indicates that that item is not present. 1 indicates that that item is present in the set. So to represent a subset of a set, these kind of masks can be used, and which is very efficiently used in programming. Now, we have discussed this how to generate the subsets of a set using bit masking concept. So if you have a set of size n, then you will get maximum 2 to the power of n subsets. So we have to create 2 to the power of n masks or binary numbers to represent all the subsets of a set. Okay. So here if a set contains only 2 items like item 1 and 2, then there will be 4 subsets, 2 to the power of 2, which is nothing but 4 subsets in the set. So what will be the mask? The mask will be either 0, 0, 0, 1, 1, 0 and 1, 1. So each represents a mask. So here the mask 0, 0 represents an empty set, and 0, 1 represents a subset having only one item, and so on. Now let us come to programming and understand how bit masking concept is used in programming. Bit masking is a very popular concept used in dynamic programming also. Now let us understand the basic program, how to check whether a particular number is even or odd. Now, to check a number is even or odd, we use very popularly the modulus operator. We use the modulus operator. Suppose the number is 8, then it is even or odd, we do 8 modulus 2. So after the modulus operator normally gives you the remainder as 1 or 0. Modulus by 2 gives you the remainder as 1 or 0. Suppose if the remainder is 0, then we say that this number is an even number. And if the number modulus 2 will give you the remainder as either 1 or 0. If the number is 8, 8 modulus 2 gives you 0, then the number is even. Suppose if I'll take n is equal to 5, 5 modulus 2 will give me the remainder as 1. So you understand that it is an odd number. So modulus is a very popular operator to check whether a number is even or odd. But the same thing we can do it with an AND operator also, bitwise AND operator also. So if I'll do the number bitwise AND operator with 1, so if the last bit of the number is set or 1, so when you do an AND operation, then it will give you the result as 1. Otherwise, it will give you the number, it will give you as 0. For example, let us take n is equal to 8. So we'll represent this number into binary. So it is 1 triple 0. So if you will see, the last bit of the number is not set. It is 0. So if you will do AND operation with 1, then what will happen? Then this bit is unset, this bit is set. So 0, 1 gives you the AND operation as 0. So when the result is 0, then you have to say that it is even. But let us consider n is equal to 7. So 7 is nothing but 1, 1 and 1. So if you will do AND operation with 1, what will happen? Both the bits are 1, so you will get the result as 1. So if the number AND operation with 1, if it is giving you 1, then you have to understand that this is an odd number. If it is giving you 0, then you have to say that it is an even number. So instead of doing the checking with modulus operator, we can also do it with bitwise AND operator. Now, how to write down the program? So in Python, first of all, we have to read a number through input method. Let us read a number which is an integer, and if the number bitwise, if the number bitwise AND with 1 gives you the result 1, then the number is odd, otherwise the number is even. It is very simple. Read a number and do bitwise AND with 1. If the result is 1, then the number is odd, otherwise the number is even. Now, let us understand second program, which is nothing but counting the number of set bits in an integer. So, set bits is nothing but the bits which are 1 are called set bits. The bits which are zeros are called clear bits or unset bits. So, we have to write a program to count the number of ones in a binary representation of an integer. So, if you read an integer, first you convert into binary and then count the number of bits which are 1. So, if my number is 1, suppose if my number is 6, then if I'll represent in binary, it is 110. So, in this number, how many bits are set? 2 bits are set. So, the binary number representation of 6 is 110 and it has 2 set bits. This would be your result. If the number is 13, then if you represent it in binary, it is 1101. You can see in the image. So, it is 1101 is 13, which is the binary representation. And you can see that 3 bits are set. So, totally, we'll say that we'll count that 3 number of set bits are there in an integer. So, the procedure is read an integer, okay, convert that number into binary and then check how many bits are 1. So, put a counter and go on counting. So, how to do this problem? Now, there are 2 ways to do this program. There are 2 ways to counting. So, one is using built-in methods. So, we have written a function called bit count, and first of all, we are passing a number. Suppose the number is 100. Now, first using the built-in method bin, we are converting this number into binary, and using the built-in method count, we are counting the number of ones in 100. So, which is giving you the result 3. Similarly, if you are sending the number as 255, then this bin method will convert 255 as all bits set. That is, all the 8 bits are set, which is 255. So, if you will count the number of ones, it is 8. So, whether it is a positive number or negative number, using the built-in method bin to convert into binary and using the method count, built-in count method, it will count the number of ones. So, instead of using the built-in methods, how will you write the same code using user-defined method? So, you can see here, we have written a method called count number of set bits and we are passing a number. So, we are reading a number, I is the number and we are passing I value. Okay. Suppose the number is 8 or I value is 8, let us say. So, here we are storing the same number into n variables. So, n is equal to 8. Initially, we have initialized a counter which is initially 0. Okay. Till the number not become 0. So, 8 is not become 0. So, while loop is true. Then, what we are doing? We are doing n and with 1. So, we are doing n is nothing but your 8 AND operation. So, what is the value of n? So, we will give 1000 as 8 AND operation with 1. So, if you do AND operation with 1, it gives you 0. So, counter will not increase. Then, you do a shift operation by 1 bit. Okay. If you are doing a shift operation, then next time the number will be 0, 1, 0, 0. So, again if you will do AND operation with 1, again it will give you 0. So, again you shift it. So, 0, 0, 1, 0. Again you AND with 1, it will give you 0. So, till that time, 3 times the counter is still 0. and again you shift one more time, so it becomes 1, and with 1, it will give you 1. So, fourth time, in the fourth iteration, the number is 1. So, you return that count value. So, this way we can count the number of set bits in an integer. Now, the way we have counted the number of set bits, also we can set a particular bit in a particular position. We call it as setting the kth bit in an integer or a number. So, one particular bit in a number, in a binary number, if you want to set it, that is called setting the kth bit of a number. Now, how to do or how to solve this problem? One simple approach is, first of all, you have to create a mask. In this bit masking, we have to first create a mask such that the kth bit in that mask will be already set. So, how to create a mask? So, you have to understand here, you take a number 1 and shift k number of times. Okay, shift k number of times, left shift you do, so that you will get that particular bit is set. Okay, now suppose we have to, the given number is 1501 and we have to set the third bit. Okay, we have to set the third bit in this 0, 1, 2, 3. This particular bit we have to set it. This particular bit is at present 0 or it is clear. We have to set this particular bit. So, we have to prepare a mask for that. So, what is the mask? This is our mask. So, our mask is this one. So, we have taken a binary number 1 and we have shifted left by 3 times or by k times, because third bit we have to set. So, 1 left shift k number of times you are doing. So, when you will do 1 left shift k number of times, we got a mask 1000. Okay. Now, then we have to apply this mask over the given number. So, what is our given number? This is our given number. 1501 is the given number, and we are doing an OR operation. This is an OR operation. We are doing with our mask, which is nothing but 1000. So, if we apply this mask, what will happen? It is 10 is 1, 0, 0. This particular bit was earlier clear. It was clear earlier. Now 0, 1 OR operation will set it. Okay. Now we'll say that this particular bit is set and 0, 0, 1. That means the kth bit or the third bit is now set in your given number. So what is the generalized formula here? You have been given a number. So you take that number, you do an OR operation with a mask. So what is that mask? That mask is nothing but which bit you want to set, kth bit you want to set. So you take 1 left shift by k number of bits. So here the number is your, whatever is your number, 150. Okay, 1 left shift with 1 mask is left shift with 3 bits, or the third bit will be set. So this is the formula for getting the number, new number, where the kth bit will be set. I hope you understood that how to set the kth bit of a number. So the simple logic is, so the kth bit you want to set. So first of all, you have to create a binary mask for that. So by doing left shift, 1 left shift by k number of times. So your mask will be prepared. This is the mask, and this mask you have to apply by doing an OR operation over the original number n. So which is the formula? N or 1 left shift by k number of times, or this is the mask. So when you do it, then you will see that the kth bit will be particularly set. Now, the way you have counted the number of set bits, the way we have set the particular kth bit of a number, we can also clear the kth bit of a number. Means earlier we have set that kth bit. Now the bit is already set. Now we are going to clear that bit from the original number. So process is similar. First of all, we have to create a mask, and then we have to apply the mask over the original number. So using which operator we have to see. So in this case, first of all, we have to create a mask. Okay. Now, we have to, how will you create a mask? So, if you want to clear the kth bit, we have to create a mask in such a manner that that particular kth bit should be 0. Remaining all bits will be 1. So, what we will do here, we'll create a mask. So, if you want to clear the kth bit, 1 left shift by k number of times. This is our mask. Okay. So, 1 left shift by 3 will give you a mask this much. Okay. But what do you want? What is our original number? This is our original number. This is our original number n. How many bits number it is? 3, 4, 5, 6, 7. It is a 7-bit number. So we have to prepare, let us prepare a 7-bit mask where that third bit should be clear. We have to prepare that mask like this. So if you will prepare a mask which is of 4 bits now, let us do it up to 7 bits. Okay. So if you will do 7-bit mask, so if you will do 7-bit mask, it will look like this: 000, 1, 000. This is our 7-bit mask. But this is our kth bit. This is our kth bit. So we have to clear this particular bit. So we'll take a negation of this particular mask. So if we'll take 1's complement of this mask, then 1's complement of this mask, it will be 1, 1, 1, 0, 1, 1, 1. So we have created a 7-bit mask by taking the 1's complement of the original mask. So original mask was nothing but 1 left shift by k number of times. This was your original mask and your number is 7-bit number. So we are just representing in a 7-bit pattern. Now we have taken the 1's complement of the mask, so which is nothing but 111, 0, 111. Okay. Now this particular mask we have to do AND operation with the original number. Let us say our original number is 1001101. This is the original number n, and this is our mask that we have 1's complement of our mask what we have prepared, and we are doing an AND operation on that. So when you do AND operation, when both the bits are set, then only it is 1, otherwise it is 0. So 1, 1 is 1, 0, 1 is 0, 1, 1 is 1. Like this, if you will check, then check the kth bit, 0, 1, 2, 3. This is the kth bit. Earlier, the kth bit was set. Now it has cleared. Now the kth bit is clear. So it is now unset or clear. So this is the procedure for clearing the kth bit of a number. So you have to remember, for setting the kth bit, you have to do OR operation with the mask, and for unsetting or for clearing the kth bit, you have to prepare the 1's complement of the mask, and then you have to do an AND operation, bitwise AND operation with the original number. These two are the shortcut formulas. Now, the same thing. Now let us understand how to get a particular bit position by writing a Python program. Now, how to get a bit? Suppose this method will give you or find out a particular bit position of a given number. So, in that bit position, if 1 is there, then you have to return true. If 0 is there, you have to return false. Okay. Now, so get bit method we are writing. We are giving a number and which bit position you want to know. Suppose it is 15. Suppose number is 15. In binary, the number is 1111. So you want to know that the bit at the second position, 0, 1, 2, 3, if you see, the bit in the second position is 0 or 1. So if it is 1, it will give you true. Okay. Suppose the number is 1, 8, which is nothing but 1, 000. Okay. Second bit, 0, 1, 2, 3. The second bit, if you want to know, this bit is clear. So it is unset already. So this will give you false. That means through this example, you are trying to know whether a particular bit is set or unset. If it is set, the method will return you true. If it is unset or not set or clear bit, then it will return you false. Okay. So this is just knowing at a particular position that particular bit is set or unset. So for this case, we have already we know already the procedure. That this is our given number. So what we will do? Number and operation with a mask. So what is our mask over here? So the number and operation with 1. Which bit you want to check, whether it is you want to get the particular bit, that particular bit or kth bit, let us say. So this is the mask you have prepared and do an AND operation. Okay. So if it is not equals to 0, then that particular bit is set. If it is equals to 0, then that particular bit is unset or clear. You have to understand like this. Now similarly, how to set a particular bit? Okay. To set a particular bit also, we will use the similar procedure, but here we will first prepare a mask. So suppose kth bit or ith bit you want to set it. So the mask will be 1 left shift by ith bit or k number of bits. Okay. So a mask will be ready. Then the number, your OR operation with the mask you have to do it. Okay. So here that set the bit. So that particular bit will be set to. Now, similarly, we have already discussed how to clear a particular bit. So, in this case, to clear, we have to take the number and we have to do AND operation with the ones complement of the mask. So, to clear the bit. Okay. So, here we have prepared the ones complement of the mask, which is N, and ones complement 1, which bit you want to clear it. So that kth bit, you have to prepare this as a mask. Take one's complement and end with n, so that particular bit will be clear. Now, after understanding how to set a bit, how to clear a bit, how to get a bit, let us understand another example, swapping of two numbers. So, you are given two numbers A and B. Okay, let us say A is equal to 4 and B is equal to 6. After swapping, A value should be 6 and B value should be 4. Now, normally, this swapping of two numbers can be solved in multiple ways, but from the bit magic concept of view, in bit magic concept, we have to understand which bitwise operator will be helpful in doing the swapping operation. Okay. Now, for this, what we will do, originally the number A is equal to 4, which is nothing but 100, and B is equal to 6, which is nothing but 110. So, as we are applying bitwise operator, first of all, we have to convert these numbers into binary. So, we have converted into binary. Then, we will do A is equal to A XOR B. So, what will happen if you will apply XOR operation? Okay, 100 XOR with 110 will give you how much? So, the XOR operator, when both the bits are different, then it is 1. When both the bits are same, then it is 0. So, when both are 0, it is 0. When both are different, it is 1. And when both are same, again it is 0. So, 0, 1, 0, which is nothing but 2. So, after doing XOR operation, you got 2. So, now our A value has changed to 0, 1, 0. So, what is the value of B? A value has changed to 0, 1, 0. What is your B value? There is no change in the B value, which is nothing but 1, 1, 0 only. Now, the second step that we have to perform is B value is nothing but A XOR B again. Okay. Now, what is the value of A? A is nothing but 0, 1, 0 and XOR with B is nothing but 1, 1, 0. So, again do it XOR 0, 0. Both are same, so 0. Both are same, so 0. Both are different, so it is 1. So, B value becomes 100, which is nothing but 4. Now, after doing these two steps, A value is 0, 1, 0, which is nothing but 2, and B value is 100, which is nothing but 4. That means the value of A we already got in B. So that means it is swapped. But the value of B we didn't get it in A. So let us do one more time. So third time we will do A is equal to A XOR B. So what is the value of A? Is 0, 1, 0. What is the value of B? Is 100. So if you will do XOR again, so both are same, so 0. Both are different, 1. Both are different, again it is 1, which is nothing but 6. So now A is changed to 1, 1, 0, which is nothing but 6. So after doing third time XOR of A or A XOR B, we got the value of B in A. So after doing this 3 steps, A and B values are swapped. Now A becomes 6 and B becomes 4. So now it is simple to just convert into any programming language. So first let us see how to do it in Python. So first of all, you have to read two numbers x comma y is equal to, we have used a map function here. So at a time we are reading two numbers. So these two numbers, how will you read? Let us say 6 and 4 we are reading, or 10 and 20 we are reading. It looks like this, 10, 20 as a string. Anything you read from the command prompt, it will look like a string. So we are splitting it. So using a split function we are splitting. So it becomes individual strings 10 and 20. And then we are applying the int function. Then 10 and 20 are converted into integer 10 and 20. And then it is mapped to the variables in the left hand side. So the first value will be stored into x. So x is equal to 10 and y is equal to 20. So this is the meaning of this first line. Okay. If you want to print before swapping what is the value of x and y, so you are printing before swap, x is 10 and y is 20. Okay. Then you understood the logic of how to do swapping of two numbers using the XOR operation. So x is equal to x XOR y is equal to again x XOR y, and x is equal to again x XOR y. So 3 times XOR operation we have applied, and after doing 3 times, x and y values are now swapped as explained in the example. So after swapping, you can print the value of x and y. You will find that x becomes 20 and y becomes 10. And we are printing those results in the print statement so that you can see that the swapping has happened between x and y value. Now, the last program of our today's session is how to add 2-bit strings. Okay. Now, given 2-bit sequences as strings, you have to write down a function to return the addition of these two sequences. Okay. Now, normally a bit string may be of different length. So, a example, suppose our string 1 is of length this much, 11000011, 7 bits length, and string 2 is only 10. Okay. So whenever you will add these two strings of different length, then how much will be the result? So the function should result you the result of 1100101 as the result. Okay. So how will you perform this operation, like adding 2-bit strings using your bit magic principle? Now, let us first understand the procedure of adding 2-bit strings, then we'll go for the programming. Okay. So, since the sizes of two strings are different, so first of all, there are multiple ways to do it. One particular way we are discussing over here, the simplest approach is first make the length of both the strings to be same or equal length. So, first make the size of the smallest string equal to the size of the bigger string by adding some leading zeros. Okay. So here you can see that first string is around your 7 bits length, second string is only 2 bits length. So leading 5 zeros you add to the second string so that both these strings will be now 7 bits. So after equalizing both these strings to the same length, then it will be easy for us to do the addition. So how will you do addition? So addition will be always done from rightmost bit to the left. From right to left we are going to add. Okay. So in every situation when 2 bits will be added, there is a chances that carry bit will be generated. So carry, if both the bits are 1, then the carry will be generated. So let us assume that there is a carry initially, which is initially 0. Okay. And if after adding 2 bits, if it generates a carry, then you have to add it to the next bit. Okay. So for doing the addition, let us understood the formula for this. So how will you compute the sum? So A XOR B XOR with a carry. Okay. So two numbers you are doing XOR A XOR B. First of all, you are performing. Whatever is the result you are getting, you are doing XOR with a carry. Okay. So if the carry bit is set, then how will you do this operation? So if the carry bit is set A and B, or B and C, or C and A. So through these operations, when both the bits are 1 here, A is equal to 1, B is equal to 1. So AND operation will give you 1 here. Okay. Or the situation may be, if B bit is 1 and C bit is 1, then the AND operation may generate 1 here. Or, okay, if carry is 1 and your A bit is 1, then also you will get 1. So there are all the three circumstances or situations you are considering. So to set the carry bit. Okay. Based on this situation, the carry bit will be set or unset. Either it will be 1 or 0. So the procedure is, first we are equalizing both the strings to the same size by adding some leading zeros to the smallest string, and then we are applying these two principles for finding out the sum value and the carry value, which should be forwarded to the next bit. Now, after understanding the procedure, let us just write down the program. Now, first of all, what is our principle? Principle is to read two numbers and make them of equal length. That is the first step. Okay. Now, let us consider the same example. String 1 is 110011 and string 2 is 10. Okay. Now, we are calling the procedure add bit string to the string 1 and string 2 we are passing. Okay. So, add bit string we are going, and string 1 is 110011 and this is our 10. Okay. Now, two strings we have passed. So, we have to get the resultant string. So, let us say initially the resultant string is empty. So, first of all, we have to make them equal length. So, we are calling a method called make equal length. We are calling a method called make equal length by passing both the strings. Okay. So, what make equal length returns? The make equal length method returns the first string, the second string, and the length of those strings. Okay. Suppose the first string is 7 bits long, then second string is 2 bits long, then it returns you the first string with 7 bits. Second string is also 7 bits and the length of this string is also 7. So it returns. So from here, we'll jump to this particular method. Okay. Now, make equal length. So two strings we are passing, string 1 and string 2. So first check what is the length of string 1 and what is the length of string 2. So if they are unequal, so check length 1 is less than length 2 or length 2 is less than length 1. That means which one is smaller, you have to check it. Okay. If length 1 is less than length 2, then you have to add the leading zeros and you have to make it equalize. Length 1 equal to length 2. Similar process we are applying. If the second string is smaller, then add the leading zeros and make length 2 equal to length 1. That means you are equalizing the length. And we are returning the string 1, string 2, both are updated. Okay. Based on any one which is smaller, that will be updated, string 1 and string 2, and the length of the strings we are returning. Okay. Now after equalizing both the strings, now we have to write down the procedure for adding and getting the carry. So for that, we have taken, there is a carry which is initially 0. Okay. Now as the addition should be bit by bit from right to left, so we have taken a for loop for I in range of the length minus 1 and we are going minus in the sense we are going back, because right to left we are going. Okay. So get the first bit of the first number and first bit of the second number. Okay. So we are calling this to be first bit and second bit. Now we have to apply the sum formula. What is the formula for sum? First bit of the first number XOR with first bit of the second number. Do that with the carry. Again XOR with the carry. And we have to make it into a string. So plus 48 we are doing. Okay. Now the resultant sum we are converting like this. And how to get the carry? The carry will be, we are getting first bit and with second bit, or second bit and with or the carry, or first bit with the carry. This is the formula for setting or clearing the carry. So based on this formula, carry will be either set or 0. Now, after getting this result and carry or sum and carry, this procedure will be repeatedly done for all the bits. Okay. So, if finally carry is still there, means all the sum of all the bits are over and carry is left out, then you have to write down the result as carry, that is carry plus the result. So the result will be 8 bits. Okay. If carry is 0, then the result will be 7 bits long. Okay. So we have to finally return the result. So here you are computing the result. If carry bit will be 1, then it will be 1 plus the result. If there is no carry, if carry is 0, then this result will be enough. That we are computing here. So finally we are going to return the result. So this is the way we are adding 2 bit strings using the XOR operator and bitwise AND operator and OR operator. So these 2 formulas you have to apply to add the 2 bit strings. So there are multiple ways to add 2 strings, and this is one of the simplest approach to add 2 strings. In this video, we understood what you mean by bit magic, how to prepare a bit mask, and how to set a bit, how to get a bit, and how to clear a bit. And we can do a number of programs using this bit logic concept. So the bitwise operators will, if you will apply for solving the problems, then the efficiency will be improved and time complexity you can check through its efficiency. So time and space complexity are the 2 parameters to check the efficiency or performance of an algorithm. And this bit magic concept is very popularly used in dynamic programming. So in the next video, we'll discuss more programs on bit masking. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.